Coding Simplified with Vandana. We're going to start with the number system conversions today. The first one in the list is decimal to binary conversion. So we'll consider some example. Say for example, this is the given decimal number which is required to be converted. See, the subscript 10 means it's a decimal number. This needs a conversion to the binary number. The subscript 2 means this number has to be converted to a binary value. We are going to use the repeated division method for this particular conversion. So this is the repeated division method. In this method, we will write the decimal number over here. That's 425 in this case. And now we are going to continuously divide this number by 2. We will repeatedly divide the given decimal number by 2. Now, why are we dividing by 2? Because it has to be converted to binary and the base for the binary number is 2. So that's the importance of this 2 over here. Let's start dividing. So this becomes 2, 1, 2 with 1 as a remainder. I'll continue this process, again divided by 2. So this becomes 1, 0, 6 with the remainder 0. Then we'll proceed further, again by 2. This will be 5 and 3. Again a remainder 0. Next is 2 with 1 carry over here. This will become 6 and 1 as the remainder. Again it will continue 1 and 3 with 0 as the remainder. Next it is 6 with 1 as the remainder. And finally it is 3 with 0 as the remainder and 1 with 1 as the remainder. Now here we will stop because finally we have got a 1 at this place. So this 1 will be carried forward and written over here. And now the numbers over here, as you can see, these are binary digits only, 1 and 0. So the final answer will be these numbers written in the reverse order. Alright, so this will be the numbers written in the reverse order. And remember the most significant bit. So this last number is your most significant bit and this first number is your least significant bit. So now you can write the number starting from this last number in the reverse order. So the given binary number is 1, 1, 0, 1, 0, 1, 0, 0 and 1. So we'll just check it once. It's 1, 1, 0, 1, 0, 1, 0, 0 and 1. So this is finally what we get as the binary number, which is the converted form of this given decimal number. So this part is done if the given question has only an integral part, as in this example. Say for example, you have another question wherein now the number is 425. Okay, so now the number is 425.75. Okay, so now this is the given decimal number which has to be converted to the binary equivalent. So to solve this, now the first part is already done. 425, which is the integral part, this has already been converted to the integer part. So this remains the same, the working remains the same. Now we are to deal with this fractional part. So to convert this fractional part into the binary equivalent, you have to follow a few steps. you will consider 0.75, and instead of dividing it as we did in the integral part case, now we are going to multiply this by 2. So we get the answer 1.50. Now, this 1 will be written immediately after the decimal point. What I mean to say is 425 has the binary equivalent that we have just found out. So we'll copy that as it is. This was the binary equivalent for 425, followed by this was the decimal point. Here it becomes the binary point. Now we want the converted binary equivalent for 75.75. So we started this working. We multiplied 0.75 with 2. The integer part will be written immediately after the decimal, this binary point. So here we'll write 1. Now we'll consider the leftover decimal part, that is the fractional part 0.50, and again we will multiply it by 2. Now in this case, we'll get the value as 1.00. Again, what we'll do, we will just consider this integer part, that is 1, and copy it as a part of the answer. What is left over now? 0.00. So here we are going to halt. This is the end of the process of multiplication. So finally we get this as the binary equivalent for this entire decimal number. I hope this conversion is clear to everyone. Decimal to binary conversion. This was the given decimal number 425.75, and it has been converted to this given binary number 110101.11.